Anyways, yes, it's an open source business model. R&D is still mainly in Istanbul, Turkey. I'm Turkish. I moved to US back again. It's 6 months ago or something, right? So I spent 7.5 years in US years ago, and moved back to Turkey and started Hazelcast there. So I'm super happy that amazing people. Now we have a lot of great guys, just like Paul and David here in the company, and also like if you look at guys like Greg Locke from EHCache or ex Tricata CTO. Like I didn't even have to invite him. Like he said, like, hey, what you're doing is amazing. I wanna join you guys and part of this fun. I'm honored, and also like if you look at guys like Rod Johnson, so it's been a nice journey. I'm thankful for everyone helping Hazelcast. A humble effort that I started years ago. Now it's quite a big one. Yes. I'm a shy person. You made me so uncomfortable here. Okay, so if you talk about technical stuff, I'll be more engaged. So so version 3 is it has multiple layers. The bottom one is networking, of course. Everything started with TCP/IP connection. We use new IO for everything. So multicast is only used for discovery. After discovery, everything is TCP/IP. So the cluster management layer is for group communication, something that JGroups does, for example. So it just creates a cluster and let the members talk to each other. So that's the clustering layer. So for discovery, we use multicast, TCP/IP, and also AWS for Amazon Web Services or OpenStack. So after discovery, as I said, it's all pure TCP/IP. Everything's new IO. So partition management used to be part of everything, right? And then we said, hey, that should be abstracted in a way that every service and we add can be partitioned, right? Maps and queues and any other service that we build can be automatically partitioned. So it's abstracted totally from maps and sets and queues. Node Engine is probably the most complicated part. It has things like threading, wait notify. When we say wait notify, it's distributed wait notify. When you do a queue.take, what you're doing is distributed wait. When you do a queue.offer, you're doing distributed notify. And when you do a map.put, you're doing a distributed invocation. And these are all part of the engine itself. And they're all abstracted with a low-level API. So the guy who implements map doesn't use any of the engine's code itself. He uses the low-level API and build everything with that. So that means if we were able to implement map and queue and executor service, even MapReduce, with the low-level API, anyone from the community can build a distributed data structure tomorrow. So it's as powerful as so map is a pretty complex thing. If you can do all that stuff, you should be able to build things like distributed actors, hierarchical map, or nested map implementation, or any data structure that you have in mind. Going back, actually, the main point of Hazelcast was that if you can give the primitive distributed data structures and also the execution patterns to the developers, then they can build any type of distributed application because it gives you the basics. Basics, distributed data structures, distributed processing units, and then you mix and match and build your own stuff, right? So abstraction helped us a lot. That way, we can quickly build any data structure tomorrow. Like it takes a couple of days for us. It may be a week for you to build a data structure. So if you know the low-level services API, you're good to go, basically. So it also changes the game. It's no longer, hey, I have a distributed map, distributed queue. It doesn't matter anymore because it's the low-level service API will make those things free, right? Everyone can build. So it's tomorrow if someone says, hey, I have a distributed this and that, who cares? I mean, just these are simple stuff anymore. So that's so we started silently promoting the low-level services API. I think this will so we'll see guys from community building custom data structures with that. Yes, so maybe one of the core features of Hazelcast is that now with the version 3 we have portable data serialization. What it means that you can write from C# and read from C++, which is pretty powerful. So that's why now that also means we can easily invest into other languages tomorrow. So Python will come in, and Perl, and all the other languages. They're going to be always natively supported. So that's the promise. Yeah, and also another thing that you see here, the on-heap and off-heap storage. These are huge stuff. So the off-heap is particularly interesting because that way we can beat garbage collection. We can give you predictability in Hazelcast. So Java is beautiful when you do processing. It's beautiful language. Everything's fine. Threading is so nice. We have frameworks, APIs to build all that stuff. But when it comes to data on JVM, that's not nice. So after a certain data size, your GC will kill you, basically. So that's why from now on we'll be investing a lot into off-heap, right? So what is the roadmap? Obviously, as I said, 2014 will be big for off-heap stuff. We'll invest a lot into off-heap storage. We already had elastic memory, which was storing values off the heap, so which was fine. So it was great, but still, that means keys and the metadata about the entries are all stored on the heap, which is terrible because if you're storing like tens of millions of entries, then you create a giant heap even for the small keys and also metadata. So and also the heap size grows as you add more entries into the map. So we started investing a lot into like storing everything off the heap, like even the metadata, keys and values, everything off the heap. So, and at some point you start to think like, how come we don't have off-heap storage in Java, like data collections in Java? Like we should have you should be able to say hash map or map, new map, new off-heap hash map or something like that, right? So then you make a decision on whether you should be using concurrent hash map or off-heap concurrent hash map. If it is off-heap concurrent hash map, everything's off the heap. That means you can store millions of entries. So I think now it's time to deal with the GC issues. Yes, one way of dealing with is the JVM garbage collection algorithms and things like that, right? So, and Azul, for example, is trying to fix that issue. But but it can be also fixed by the API. So I'm just remembering the days where Doug Lee was trying to fix the concurrency issue with the if you remember the concurrency library in 2003. And now it was like super obvious that that thing should be in Java, right? So and then it became, now it is in Java. But now like after seeing the benefit of off-heap, like you see like that thing should be inside the Java, and you should be able to say new off-heap concurrent map. That's it. That should be. But so now like nowadays there's common talk. You should give 4, 6, 8 gigabyte heap size to deal with the GC. So it's a very limiting thing. And the people started talking about like running multiple JVMs on the same machine, even on the same virtual machine. Like you already have an abstraction, right? So you say I'm gonna have multiple VMs on the machine, and then you say I'm gonna run multiple JVMs on the machine. Why? Because GC and everything else. So that's of course CPU utilization is one part of the thing, but still mainly it's about GC problem. So we'll keep investing in off-heap storage. When I say off-heap, it means still NIVIO memory. I'm not talking about disk here at least. We already have memories, right?
Yeah. So MapReduce is part of 3.2, and 3.2 is released.
Will be released in any moment. So
literally any day now. So if any of you have been looking at the website and been downloading, so we've gone through various different release candidate stages. MapReduce is in there. It's a very Hadoop-like API. Mm-hmm. So that's going to be available in a production ready state. I would say this week. I think that's going to be released.
Yeah. Schedule executor service is an extension to executor service. So we go with the. I mean, of course, we listen community, and if there's a common request all the time, then we tend to implement that eventually. So schedule and executor service, for example, was one of the highly requested feature. So disk is also another one. So you're just thinking like, okay, so everything is in memory. What if the entire cluster go down? So you lose all that stuff. Okay, so you have the data somewhere else. Maybe you can reload it, but it will take a lot of time to read from a centralized location. And then you say, and how am I going to upgrade my application? Because I have data in memory. I don't want to lose it. So I heard that story again and again so many times that now it's time to, I think, fix that issue. So we should be able to at least like dump the content to disk, upgrade the application, just put it up again, and don't lose the data. So that's one of the things that.
Yeah, I mean that was a common use case or common problem on the last project I was at. We had a market aid system that had it had maybe 100 gigabytes of data in it, and the backing store was a Sybase database. And if we had a cluster freeze or crash in the middle of the day, right, you have to bring the whole thing down sometimes, bring it up, and you're down for a quarter of an hour, 20 minutes, while you're waiting for the database to restore the cluster.
Yeah, if there's a way to like super fast restart, then it's a big win. So that's also one of the big features that we want to have in 2014. JCache.
Mr. Greg Luck.
Mr. Greg Luck, yes.
So Greg is the when Greg was working at Terracotta. So as Talip said, Greg is now our new CTO. So we'll be dragging Greg over here. He's a real Australian charmer, so we'll get him on the stage and have him talk in maybe one of our user groups. But Greg was one of the spec leads on JSR 107, along with Brian Oliver, who I'm sure a lot of people know as well, Coherence. And for some bizarre reason, Greg's quite fond of telling everyone that JSR 107 It's the longest running spec ever. Is it 10 years, 11 years?
10, 11 years, yes.
But to Greg's credit, he wasn't actually on it for that full period of time, I think. I think if we're going to credit Greg, it's for actually, and Brian, obviously, with those two guys really pushing through the spec.
Yeah.
So J Cache is now going to become a standard. Hazelcast will be implementing it, obviously because we have Greg on the team, along with our other friends. It's just something that it's a great way for people to try out different cache vendors, right? Think of it as JUBC for caches, is what I always tell people.
Yeah, it will be part of Java ES 8, which is very good also. So yes, we will invest a lot in JCache, and we'll go with this standard. We want to lead this standard too.